This lesson is on 2.5, which is solving equations using addition and subtraction. The vocabulary we need to know for this section includes inverse operations, which are two operations that undo each other, such as addition and subtraction. So for example, x plus 2 minus 2 is just going to leave you with x, because the plus 2 and the minus 2 cancel each other out because they're inverse. The second is equivalent equations. So equivalent equations are equations that have the same solution. So for example, 5x, which is equal to, let's say, x times x. So in this case, x when equal to 5 is going to be equal on both sides of the equation. So these are equivalent equations. There's also two kind of rules we need to learn for this, or properties as we call them in math. And they are the subtraction property of equality, which means that subtracting the same number from each side of an equation will produce an equivalent equation. So we could divide both sides by x here, or a number, and it would still be equivalent because I've done it to both sides. So let's go through another example. So if x plus 3 equals 5, then x plus 3 minus 3, these two will cancel out because they're inverse, equals 5 minus 3. So we put the minus 3 on both sides, or x equals 2. So we've now solved for x because we got x alone by using the inverse to move the 3 or cancel out the 3. So for example, x plus a equals b. If we subtract a from both sides, then we get x equals b minus a. So that's for the subtraction property of equality, and it's used to cancel out or use the inverse operation of addition, which is subtraction. Then the alternative is the opposite, the addition property of equality. So if we add the same number to each side of an equation, then we produce an equivalent equation. So actually my example up here wasn't great. That's what we're going to get to in the next section. But if we were to subtract both sides or add the same number to both sides, so 5x plus 2 equals x squared plus 2. So as long as whatever we're doing happens on both sides, it's going to be true. So here we had x minus 3 equals 5. So if we add 3 to both sides, these cancel out. So we're left with x equals 8 because 5 plus 3 equals 8. So I'm going to give you some practice problems for this. So let's go through an example together. So let's solve the problem n plus 12 equals 7. Not using mental math, now we're going to actually use algebra. So the first thing you can do is subtract the 12 from both sides. So if we subtract 12 from both sides, these 12 cancel out on this side, and we get 7 minus 12 on the other side, which is equal to 5. And then we can go back and check our solution by plugging that negative 5 back in for m in the original equation. So if we get negative 5 plus 12 equals 7, we've checked that. That is correct and true. So now we've checked it. Another example would be using addition. So if we had negative 2 equals x minus 9, the goal is we want to get this x alone. So in order to do that, we have to add 9 to both sides to cancel it out. So this cancels getting our x alone. So negative 2 plus 9, as written below, is going to equal 7. So 7 equals x. We plug it back into the original, which let me erase it so we can see it. So now we have negative 2 equals 7 minus 9. That is equal to negative 2. So good, we are correct. So we can go back and say, yes, this is our answer for each of these problems. The third example is writing and solving an equation. Just like the previous sections, we always use something with some type of word problem. So how can we write this out? So you're traveling to Louisville, Kentucky. You have already traveled 122 miles, and you just passed a road sign that Louisville is still 76 miles away. And we want to know how far is Louisville from the start of your trip. So if we write a verbal model, letting D represent the distance from the start of your trip, so that's our blue. So the distance from the start of our trip, which is D, minus the distance traveled. Well, we traveled 122 miles. And the remaining distance, well, we saw the sign that says we have 76 miles to go. So then we can write it as our equation, D minus 122 equals 76. We then can add 122 to both sides and get finally that D equals 198. But it's a word problem. So actually we need to make sure we say miles from the start of your trip, or at least miles as the label. So those are the only 3 examples of types of problems in this section. So what I want you to do is, I gave you a few extra practice problems, but try practice problems 1 through 6 using those properties we learned of subtraction property of equality and the addition property of equality, and then also use a verbal model and equation in order to solve for the 2 word problems 7 and 8. That's it for today. Bring these into class with you tomorrow, and we'll go over any questions you may have.